Hello everybody, we are still talking about the mass transfer in different phases, and the last thing we mentioned in the previous video was the balance equation or the mole balance around or on the interface, and we said the flux in the liquid phase side equals to the flux in the gas phase side, and we were able to write the equation in this form, and we said that this is a straight line equation. And since we are gonna deal with these kind of equations a lot, either here or in any mass transfer processes later, then we have to understand how to deal with the straight lines. And this seems to be a very simple and basic piece of information, but actually based on my experience with the students and with dealing with these or the problems that include drawing straight lines, I believe sometimes the shape or the information given about the straight line will make drawing straight lines kind of tricky. So this is why I want to dedicate this video for drawing straight lines and using the information that we know to draw straight lines. Especially with some issues that we face with the givens that we have in this type of problems. So let's say I have this straight line. The general information or the general form of the equation of a straight line is y equals slope multiplied by x plus intercept. So y and x are any values that satisfy the equation, or any point that satisfy the equation is x and y. So like x1, y1, x2, y2. You have here infinite number of points. Any point between these two points on the line will satisfy the equation, which means that you will, if you substitute with the value of x in here, then the right hand side will be equal to the y that you have. This is valid also for any value of x and y that satisfy the equation, even if it's larger than x2 or smaller than x1. So it's valid for the range of negative infinity to positive infinity. So there is no limit for the number of points that you have. So there are infinite number of points that satisfy the equation. And since we have two parameters here, the slope and the intercept, then the equation can be fully defined by the knowledge of two information, and these two information can be the slope and the intercept. And in this case, it's gonna be like a piece of cake. It's easy to draw a straight line. You just put any 2 points and then you draw it. But sometimes it's written in other form. Let's say I will substitute with x1, y1 and x2 and y2 in this equation. Then we will have these two equations: y1 equals ax1 plus b and y2 equals ax2 plus b. So these are the two equations. We can combine the first two equations, this and this, to get to subtract y minus y1, then ax minus x1 equals a multiplied by x minus x1. And then we can rewrite the equation in form of slope equals delta y over delta x. This is one other way of representing a straight line equation. And here the a is the slope, x1, y1 is the point, and xy is any point that satisfies the equation. You can also write it in terms of 2 points here, as in this case. So it's y2, x2 is a point, x1, y1 is a point, and a is the slope. So we can use this form also to define the equation. So if I know in this case, if I know the 2 points x1, y1 and x2, y2, these 2 points here, then I can simply draw the straight line, because this is as simple as this. I will put this point here, and draw the straight line. So this I just want to confirm with you that, or make sure that you know that this is or these are different forms of expressing a straight line equation. Okay, so now we can compare the equations or the forms that we have to the form that we got from the mole balance on the interface, and you would see that this is a straight line equation. In most of the cases, we have constant mass transfer coefficients KL and KG. So the slope is constant. I know point PA and CAL, and the other point is PA and CA interface, both at the interface. So this is a straight line that passes by 2 points. And now comes the issue. In almost all the cases that we have, we will be able to know values for the bulk partial pressure and bulk composition. I know PA and CAL, and I know the slope, but I cannot or I don't know the interfacial concentrations. In many cases, this is the requirement that I want from the problem to get the interfacial concentration. Sometimes it's not easy to get as a parameter to be measured, so we calculate it based on the information that we have. And now comes the problem: how can I draw a straight line if I know a point and a slope? This is the question. This might seem very simple to you, but believe me, this is kind of tricky for many people. So if you can do it yourself, then I believe you are smart enough and you don't need to watch the rest of this video. But for those who cannot know or don't know how to draw these straight lines with the given information, then this will be helpful for you. So I have here an equation where I know y1 and x1, which is a point that I have here. And the equation is y minus y1 over x minus x1 equals a. So I know a point and a slope, and based on my understanding, a straight line needs two information. So I have already two information. I have a point and a slope. So these should be enough for me to draw the line. I don't need any extra information to be able to solve this or draw this straight line. And again, to have an idea how we will draw it, please always remember that straight line can be defined using any 2 points. Again, any 2 points. These 2 points are not necessarily, if I go back here, these 2 points are not necessarily the PAL and PA and CAL and PA interface and C interface. It's not necessarily these 2 points. Any 2 points that satisfy the equation would be enough. So let's say in this case, if I know x1, y1, and I know a point here, if I connect these two lines, then I know the straight line. I can extend the straight line. I can extrapolate the straight line, extend it to for values less than x1 or greater than x2. If I know a point here, if I know a point in the middle, any point that satisfies the equation is enough with the known point that I have. So this is an information that you have to understand. If I want to draw the line, I'm not concerned now about getting the interfacial concentrations. I just want to draw the line. I can get the interfacial concentrations using another information that we will know later, but I'm talking now about drawing a straight line. I know this is the equation of the straight line. I know this point and I know the slope. I can draw the straight line using the given information. It's not necessarily drawing the line using these 2 points. It's just one form of the equation that satisfies that tells me that these 2 points satisfy the equation. If I have this equation written in terms of x2 y2 and x3 y3, it's gonna be the same. It doesn't mean that x1 y1 is not satisfying the equation. It doesn't say that, but it says that I have any 2 points can satisfy the equation. I chose any 2 points. So this is the point that I want you to keep in mind. You need 1 point, any point. It doesn't have to be the interfacial concentration. Just need any point. I know I'm emphasizing on this a lot, but please keep in mind that I'm saying this based on my experience with the students. They have or they really struggle to get the second point, and they want the second point to be the interfacial concentration. And if I'm smart enough to get the interfacial concentrations by drawing the line, then why would I bother myself to draw the line? If I know these points already, so there is nothing I need to do. So the problem is already solved. So I need any other point to draw the line, and from this line I can get the interfacial concentration. So this is the point. So back to the case that we have. I need another point. Any other point is gonna be enough for me to draw the line. So it's as simple as getting any random point. So I can rearrange the equation to be in this form. So it's y equals y1 plus a multiplied by x minus x1. So I just multiply these two and get y1 on the other side, and the equation is already it's the same. It's just another form. So I need any other point. Let's say the value of x1 here is 1. Let's say this is 1. And I need any other point. So I can put any value of x here. I can put x equals 2, 3, 4, 0, negative 1. Put any value of x of course it's not x1, just put any value other than x1, and if you put any value here of x2, let's say I put x2 equals 5, then I'll get value of y that corresponds to this x2. So it means that I have another point. So this is as simple as this. The problem is solved. Just substitute with any value of x and get the corresponding value of y. Now you have another point, and you can just draw a straight line that connects these 2 points, and if you want, you can extend the line for values larger than x2, smaller than x1, based on your need. But the straight line is already there. You don't need to do anything more. It's already there, and you can extend it from negative infinity to positive infinity. The straight line is drawn, and you're done. It's just as simple as this. So just think of the straight line equation as an equation or a straight line that or a line that needs 2 points. You just need 2 points. If you have a point and the slope, use the point and the slope to get another point, and from this point you draw the straight line. And later you can think of another information that you need to have in order to get the interfacial concentration. But once you have the 2 points, you can draw the straight line, which will be 1 point on this straight line will be the interfacial concentration. But you know, it's instead of having it in all this large area, it's now part of this or point on this straight line, which will make life much easier. So what we're gonna do next time is we will see how this will fit with what we have, and how we can represent the information that we know on a graphical way, or using a graphical way, and how this will help us solve the problems to get the interfacial concentrations and the flux, and how this will save a lot of time, and how this will give us a lot of understanding of what's taking place in the process. So this is going to be the topic of the next video. So I'll see you then, inshallah. Goodbye.